Hello and welcome to revision classes on television. Today, we will be having a session in mathematics. Our guide is Abiodun Idowu, and our focus today is surds.
What are surds? Surds are set of irrational numbers. We refer to them as irrational numbers because we cannot express surds with an integer. They are always going to come up with recurring fractions or decimals. Examples of surds. Let me write the definition of surds on the board first. Surds are sets of irrational numbers because we cannot represent them with integers. Now, what are the examples of surds? Examples are root 2, root 3, root 5, and so on. If I need to evaluate root 2, I'm going to come up with 1.4 and so on. That is a recurring decimal. The same thing is applicable to root 3 and root 5. That is actually why this collection is referred to as surds. But we have another type that they will have the square root sign, but they are not surds. Examples are, if we have root 4, root 9, root 16, root 25. If you look at all these ones on the board, they are not surd. Why are they not surd? Because root 4 is the same as 2, and 2 is an integer. Root 9 is the same as 3, and 3 is an integer. So what I'm trying to tell you is that root 4, root 9, root 16, and root 25, they are not surd. Are not surds. Why are they not surd? Despite the fact that we use them anytime we are solving problems involving surds, does not make them surd because they are not irrational numbers. 2 is a whole number. It is not a recurring decimal like root 2. Likewise, 4 is a whole number. It's not a recurring decimal like in case of root 5. So you need to know how to distinguish between a surd and a number that is not surd, despite the fact that we are going to be working with both of them. So at this point, I'm going to talk about how do you simplify a surd, or how do you simplify surds. To simplify surds, you have to be mindful of perfect squares. That is, if I want to simplify surd, my attention should be on perfect squares. Now, what are perfect squares? These are numbers with integer square roots. Now, I'll list some of them on the board. Integers square roots. Examples, we have 1, we have 4, we have 9, 25, 36, 49, 81, 64, 100, 121, 144. Anytime I need to simplify surd, these are the numbers I have to put into consideration. I'll use this. If any one of them is a factor of the surd I need to simplify, then I have to use this particular number. That is, I have to use those ones that are perfect squares. Another way of simplifying a surd, especially fractional surd, is to apply what we call rationalization. If I have a surd as part of my denominator, then I'm going to use the method we refer to as rationalization to simplify. What do I mean? If I need to simplify something like 3 divided by root 2, because my denominator is a surd, then I'm going to rationalize by multiplying by root 2 divided by another root 2. What I've done here, the procedure is called rationalization. I've not actually changed the question, because if you look at root 2 all over root 2, it is the same as 1. So I can do the multiplication. 3 multiplied by root 2 is going to be 3 root 2. Root 2 multiplied by root 2 is going to be 2. As far as I don't have any surd in my denominator, I've been able to simplify 3 divided by root 2. So those are the 2 lines of simplification we are going to be looking through anytime we are simplifying a surd. Now we are going to look at an example to illustrate how to simplify a surd. The particular question, if root 2 plus 3 divided by root 3 is simplified as m plus n into root 6, we have to find the value of m plus n. So for this question, the solution can go this way. Since there is a single denominator, I can split the 2 into 2 different parts. That is, having root 2 plus root 3 all divided by root 3 can be written as root 2 divided by root 3 plus root 3 divided by root 3. So at this point, this is the same as root 2 divided by root 3 plus 1, because root 3 divided by root 3 is going to be 1. Now there is need for me to rationalize this particular side. So to rationalize that, I'll multiply by root 3 divided by root 3. Then I have my plus 1. So root 2 times root 3 is going to be root 6. Then root 3 times root 3 is going to be 3. Then plus 1. So at this point, I can write my result as 1/3 root 6 plus 1. This result can also be written such that 1 will come first. That is 1 plus 1/3 root 6. If I compare this with m plus n root 6, it implies that m is the same as 1 and n is going to be 1/3. The examiners want me to find the value of m plus n. So what it implies is I need to add 1 and 1/3 together. So adding the 2 of them together, my 1 can be written as 3 all over 3 plus 1/3. That is 3 all over 3 is still the same thing as 1. So that the addition will finally be 4 out of 3, or 1/3. So we've been able to find the value of m plus n as required by the question. This is another question we are required to simplify. If you look at this, we have a surd in the denominator, and that surd can be simplified. So I'm going to start with the simplification of that surd. So the solution of this, I can say this is 15 divided by root 75 can be broken down using the perfect square. So I'm going to write it as root 25 multiplied by root 3, then plus root 108 can also be broken down using the perfect square. So I'm going to write it as root 36 multiplied by root 3. I'm using the perfect square. 36 is a perfect square. 25 is a perfect square. Likewise, root 432 can be broken down to be root 144 multiplied by root 3. So at this point, I'll now start simplification. So root 25 is actually going to be 5. So this will be 15 divided by 5 root 3. Because root 25 is 5. Plus root 36 is 6 root 3. Root 144 is 12 root 3. So I can simplify this. 15 divided by 5 is going to be 1/3. It's going to be 3. So this is 3 divided by root 3 plus 6 root 3 plus 12 root 3. So there is need for me to rationalize this because it's having a surd in the denominator. So this will be 3 out of root 3 multiplied by root 3 out of root 3 again, then plus 6 root 3 plus 12 root 3. This multiplied by this will be 3 root 3 divided by root 3 times root 3 is going to be 3. Then plus 6 root 3 plus 12 root 3. So at this point, 3 can cancel out 3. So I'm going to be left with root 3 plus 6 root 3, then plus 12 root 3. So I'm going to do my addition. Root 3 plus 6 root 3 is going to be 7 root 3. That is these two, 7 root 3, then plus 12 root 3. So doing this addition, I'm going to have 19 root 3 as the final result. It's like saying 7 root 3 plus 12 root 3 is going to be 19 root 3. You can put the solution down in your notebooks. So we have question number 3 on the board. We are required to simplify root 2 into root 6 plus 2 root 2, bracket closed, minus 2 root 3. So to answer this, we are going to remove the bracket first. We have root 2 into root 6 plus 2 root 2 minus 2 root 3. To remove the bracket, we have root 2 multiplied by root 6. That is going to be root 12. Then root 2 multiplied by 2 root 2 is going to be 2 multiplied by 2. What happened here is that this particular 2 is the one here. Then root 2 multiplied by root 2 is 2. Then I'm going to add this finally. That is minus 2 root 3. So at this point, I can simplify root 12. I'm going to simplify root 12 using the perfect square. The perfect square that is a factor of 12 is 4. So instead of writing root 12, I'm going to write root 4 into root 3. Then 2 times 2 is going to be 4. Then minus 2 root 3. The root of 4 is 2. Why this will remain as root 3, then plus 4 minus 2 root 3. So at this point, we can only add surds together. We cannot add a surd and a number together. So in this case, I'm going to bring this sword and this particular one together. So I have 2 root 3 minus 2 root 3. Then the number will now follow. So 2 root 3 minus 2 root 3 is 0. So we are actually left with 4. So if I need to simplify this particular expression on the board, I'm going to end with what? 4. The first thing we do is to remove the brackets. After removing bracket, bring all the sorts together, and then we simplify accordingly. And when we are simplifying sort, we have two modes. We simplify using the perfect square, or we simplify by rationalization. We have been coming across simple rationalization. It's not that maybe the solution is just the way I've solved it exactly. There are so many methods that can be adopted, and if you are adopting those methods, provided what you are doing is correct, we are getting the same result. You can put this result in your notes. Looking at question number 4, we are asked to simplify 2 root 28 minus 3 root 50 plus root 72. So the solution to this, we have 2 root 28 minus 3 root 50, then plus root 72. We'll simplify using the perfect squares. So root 28 can be written as root 4. We are using 4 before because 4 is a perfect square. Then this is root 7. Root 4 multiplied by root 7 is root 28. We are going to simplify this also. We have 3. Root 50 can be expressed as root 25 multiplied by root 2. Then plus root 72 can be expressed as root 36 multiplied by root 2. So at this point, we'll simplify those perfect square that we have. So this is 2. Root of 4 is 2. Then I have root 7. Then this is 3. Root 25 is 5. Then I have root 2. Then root 36 is 6. Then I have root 2. So 2 times 2 is 4 root 7. Minus 3 times 5 is 15 root 2. Then plus 6 root 2. We have similar sort here. They are both in root 2. So this is 4 root 7 minus 15 root 2 plus 6 root 2 will be minus 9 root 2. So at this point, this is root 7 and this is root 2. They are not similar sort, so our simplification cannot go beyond this level unless we want to put it in decimal. So we are going to stop at this particular level because they are not similar sort. You can put the solution in your notebooks. Looking at this particular question, we are to simplify root 108 plus root 125 minus root 75. So our solution, we have root 108 plus root 125, then minus root 75. Root 108 is the same as root 36 multiplied by root 3. Root 125 is the same as root 25 multiplied by root 5. And root 75 is the same as root 25 multiplied by root 3. So at this point, we'll simplify. Root 36 is 6, root 3. That is, this is 6, then the root 3. Plus root 25 is 5, then this root 5 will be in place. Then minus root 25 here is also 5, root 3. Now we are going to bring the similar sorts together. 6 root 3 and 5 root 3 will come together. So we have 6 root 3 minus 5 root 3, then plus 5 root 5. So 6 root 3 minus 5 root 3 is just going to be root 3. Then we now have plus 5 root 5. So at this point, there's nothing we can do again. We have been able to simplify the expression, so we can put our results down. Now moving on to question number 6, we are required to simplify 3 minus root 2 all divided by 4 plus root 3. So to simplify this, we have a binomial sort as the denominator. So we are going to use the conjugate of the denominator. What is the conjugate of this particular binomial sort? It is still going to be 4, but the sign will be reversed. That is, we'll alternate the sign. The sign is now going to be negative. Instead of using 4 plus root 3, I'm going to use 4 minus root 3. If it were to be minus that we have there, I'll use plus. So what I'm going to do is to write the main question given, which is this. Then, because I have 4 plus root 3, I'm going to multiply by the conjugate, which is going to be 4 minus root 3 divided by 4 minus root 3. Now at this point, let me remove this multiplication sign because the bracket can serve the purpose of multiplication. Now 3 minus root 2 multiplied by 4 minus root 3. That is, we have 3 minus root 2 multiplying 4 minus root 3. All divided by 4 plus root 3 multiplying 4 minus root 3. If you look at this, we have the expansion of difference of two squares. So instead of doing an elaborate work here, I can write this to be 4 squared. That is the square of the 4. It will always be minus, then root 3 squared. If you multiply this with this, the denominator, you get this. So let me expand the bracket in the numerator. 3 multiplied by 4 is 12. 3 multiplied by minus root 3 is going to be minus 3 root 3. Minus 2 multiplied by 4 will be minus 4 root 2. Minus 2 multiplied by minus root 3 is going to be plus root 6. All divided by 4 squared is 16. Root 3 squared is 3. So at this point, there's nothing I can simplify in the numerator again because we don't have similar sort. It's only one number we have there, which is 12. So we can leave the numerator the way it appears. But the denominator, 16 minus 3, is actually going to be 13. So I can write my final result as 12 minus 3 root 3 minus 4 root 2 plus 6. This is root 6. Then we now have 13. So we've been able to simplify this particular fractional sort. When you have a binomial sort like this particular one, the conjugate will just be when we change the sign. If it is plus, we change it to minus. If it is minus, we change it to plus. Then we now rationalize. What we are doing here is to rationalize. This will not in any way change the question because if you cross this out, it's just like multiplying the main question by 1. So the procedure is still intact. We're actually simplifying that particular fractional sort. Now, two things we have mentioned here. If you need to simplify a sort, it's either you are working with the perfect square or you are rationalizing using the conjugate of the sort you have in the denominator. So anytime you are to simplify a sort, the options that must come to mind is for you to pay attention to the perfect squares. The perfect squares are number 1, number 4, number 9, number 36, number 16, number 25, number 36, and so on. So you can use the perfect square. And if you are not using a perfect square, if you are dealing with a fractional sort, then you rationalize the fractional sort by looking at the denominator. Use the conjugate of the denominator in case of a fractional sort. And then remember, you can only add or subtract similar sort. Before you start addition or subtraction, you have to ensure that you simplify the sort so that you'll be able to see similar sorts. Because if they are not similar sorts, you cannot do addition. If they are not similar, you cannot do subtraction. Take note of this fact and put the result in your notebooks.
You can subscribe to NTA series on YouTube to watch or download past episodes of revision classes on television. That's the much we can take on the program today. Do join us next time for another educating session.